Hello, everyone. Welcome to our Succeed with Variable Rate webinar. Thanks for taking the time to join us. My name is Chris Hawkins. I'm the Sales and Communications Manager with CropPro Consulting. I'll be your moderator for this session. Our plan is to be as efficient as possible with the time that you've given us. So we've pre-recorded each of our presentations. They should take about 40 minutes to go through. After that, we'll transition into a live Q&A session where we can answer any questions that you may have. You'll notice each of your microphones have been muted. That way we can stay focused and on track. We certainly do encourage your questions though. So as you think of them, simply press the Q&A button on the bottom of your screen and type your question into the submenu that pops up. I'll be sure to ask your questions on your behalf at the end of the presentations. For those of you not familiar with CropPro Consulting, we are a fully independent agronomy company and we started business in 2003. In 2008, we started doing variable rate using our SWAT MAPS technology. Today, we have 13 sampling trucks, 6 mapping trucks, and 25 staff throughout the province. Our client base continues to grow because people are starting to realize that we do have the expertise to help them succeed with variable rate. This is validated by the fact that we have over 95% client acre retention rate year after year. So we're proud to share some of that expertise with you today. But before we do that, we're going to ask Carrie DeGoyer to spend time explaining to you what SWAT maps are and why we need them. Carrie DeGoyer is our operations manager and also our senior precision agronomist. She's a professional agrologist and a certified crop advisor. She grew up on a mixed farm just outside of Sheeho and currently makes her home in Melfort, Saskatchewan. She got her university degree in agriculture from the University of Saskatchewan, where she focused on crop science. She joined CropPro in 2014, and part of her role includes providing precision agronomy service to Melfort and northern Saskatchewan. She truly is a proven SWAT MAPS agronomy expert. She's going to spend about 10 minutes going through what SWAT MAPS are, and then I'll introduce our main speakers. So without any further delay, please welcome Carrie DeGoyer.
Thank you, Chris, for the introduction. Welcome, everyone. As you said, if you have any questions as we're going along, please put them in the Q&A or wait till we're done and ask them live. So what we're doing is we are mapping soil potential, and the map that we build becomes the starting point for everything that we do next. It's the basis for our soil testing locations and also our fertilizer recommendations. So in essence, what we're doing is we're capturing soil, water, and topography attributes from your field. So take what you're seeing in your field and putting it in a zone map. So taking what we're seeing in your field and putting it in a digital format so that we can manage each area appropriately. So along the bottom, I threw up some example SWAT zone maps overlaid on 3D models of some fields that we work with. And the 3D model is exaggerated just to really highlight and emphasize where the hilltops are versus the depressions. And if you look at our legend, each color on the zone map is its own management zone. So right off the bat, you can see all the high and dry hilltop areas of the field are their own zone. They're managed differently than the rest of the field. And then on the other end of the spectrum, all the water collecting depressions are their own zone as well. So you kind of see where we're going with this. I threw up a field here that was summer followed. And if we still summer followed all our fields, this is very typical of what we would see. You see this hilltop in the foreground and then some hills in the background. They're all drier. They're usually lighter textured soil, definitely lighter colored soil, and also usually a thinner topsoil depth. And then you compare that to as you go into the mid slopes and then these depressions, the depressions are wetter, usually higher organic matter levels, and a thicker topsoil depth. So this is what we would see in our fields, or this is what we do see in our fields. We want to get a map of this because the crop up on this hilltop versus this depression are going to respond to fertilizer differently and yield differently. So we want to make a map of that. How do we do that? We go out and we physically map your fields with our mapping trucks. So I threw up a picture of one of our mapping truck setups. You can see this contraption here. This is a SWAT box. It's got an EM38 in it, and it's measuring electrical conductivity. And then we've also got this RTK base station set up. And as the truck is driving around the field, it's capturing elevation and topography data. So those two layers put together, the EC layer and the elevation topography layer, they capture a number of things. One of the things they capture is soil texture differences. That's what the EC layer is doing. It's going to delineate where the lighter textured soils are versus the heavier textured soils so that we can manage them separately. It's also going to capture salinity. Not every field has salinity, but if you do have salinity, it's going to really pinpoint where that is so that we can manage that area separately from the rest of the fields. A lot of fields actually have light salinity that maybe isn't particularly visible to the naked eye, but the EC layer will capture that as well. And then, of course, for capturing water runs, depressions, and hilltops. So if you think of your own fields as you're combining them, they're not yielding the same corner to corner. You have variability. Now, what causes that variability? It can be 100 different things. It can be man-made. It could be related to insect pressure. It could be related to weed pressure, or it could be related to some fertility-based factors in the field. Things like soil. If you think of your own field, you likely have different topsoil depths and organic matter levels in different areas of the field. If you think of water, where is it dry versus where is it wet? Water's always running somewhere. And this is going to have a big impact on how the crop yields and how the crop is going to respond to fertilizer in those different areas. And then, of course, topography. So threw up another example, SWAT zone map overlaid on a 3D model again. And as I said before, the 3D model is over exaggerated just to really accentuate where the hills and depressions are. But looks like there's mountains in this field. There's not. But right away, you can see that all these high and dry parts of the field are zone 1 and 2. And then as you go into the mid slopes and the more water collecting areas of the field, you get into the zone 10s. So this map is really capturing the fertility-based variability factors in your field, the different soil types and textures and depths, and where the water is going. One last step before we choose a SWAT zone map is we go out and ground truth it. And what that just means is the agronomists go out and make sure that the map we chose matches the field perfectly. So as the agronomist goes out in this field and they're driving around in a zone 1 area, when they're out in the field, it better be the highest and driest part of the field. On the other end of the spectrum, this is that same example field. This particular field has very high salinity. So when they're ground truthing a field like this, all the very highly saline spots need to be in a zone 10 so that we can manage them completely separately from the rest of the field. Like I said, not all fields have salinity. So if you have a field that doesn't have salinity or fields that don't have salinity, the zone 10 is always the most water collecting area of the field. So it's the areas of the field where water runs to after a big rainstorm. So we've chosen a map. The next step is we go out and soil test it. And our zone maps are 10 zones, but we sample to 5 zones. And this gives us a really, really good idea of what's going on in the field in all areas of the field. If you compare that to composite soil testing, with composite soil testing, you're collecting soil from the mid-slope areas of the field, putting them in a bag, sending them off to the lab. That's a 1 zone soil sampling procedure. We sample to 5 zones. So with the ones, if the sampling truck is in sampling this field, they go to all the 1 areas, collect cores from there. and put that soil in a bag to go to the lab. And all the soil from this zone should be very similar. They should all be the lightest textured soils in the field, the driest soil in the field. So it makes sense that they're grouped together. And then on the other end of the spectrum, the 5s, this is the most wet, most saline parts of the field. And then we sample 3 zones in between. So these points are all GPS referenced, so we go to them every single year. So we also get a really good picture of what goes on year to year. So how are SWAT maps different? This is a map based on soil properties, and this is really important because we are applying inputs to the soil. So it makes sense that we start with what's going on in the soil. And our SWAT maps can give you an answer to why your crop is yielding the way it is in certain parts of the field. If you were to compare that to making zones from yield or satellite imagery, those don't give you the whys. They just tell you what the crop yielded at that certain point in time. And the big problem with them is that they can group areas together that shouldn't be grouped together. So what I mean by that is you might have a medium yielding hilltop, and you might also have a medium yielding depression. So the satellite image is grouping those 2 areas together. They're both medium yielding, but the soil properties are nothing alike. The crop in those areas are going to respond to fertilizer differently. So that's why we need to use SWAT maps to make a zone map, because we're applying inputs to the soil. It matches the field so that we can manage each area appropriately. And the key point, I guess, is different areas of the field, the crop is going to respond to fertilizer differently. So if we're taking your existing fertilizer budget, you're already spending the money on the fertilizer, we're better able to put that fertilizer where the crop is going to respond more, so where you're going to get the optimum return. So this is my last slide. Not all variable rate is the same. I went through how we map your soil potential and soil test the field. This becomes the basis for what happens next. I didn't go through what happens next. That's where the agronomists in the next section will go through some specific strategies they use in the area. The last point is just saying that everybody's fields and soil test results are different. So what is the value of SWAT maps? We could give specific examples of 10 different ways we can provide value. And those will have a cumulative effect. Some of the strategies you might put more weight on certain fields than others, but both in the long term and the short term, you will see value to using SWAT maps. And I think the key point is that we have a really high client retention rate year over year. If our clients felt like we weren't providing value to them with our fertilizer recommendations and agronomy recommendations, they could leave us. We don't make anyone sign multi-year contracts or anything like that. So our clients are having success with variable rates because we are starting with a really good base. We're starting with a map that captures soil potential.
Thanks, Carrie, for that great information. Now it's time to hear from Hana and Michelle, our local SWAT MAPS agronomy experts. Hana Roof is a senior precision agronomist here at CropPro. She's an articling agrologist, as well as a certified crop advisor. She grew up on a grain farm just outside of Ryan, Saskatchewan, and currently makes her home just outside of Yorkton. Hana received her agriculture degree from the University of Saskatchewan, where she focused on soil science, and she joined us at CropPro here in 2017. Michelle Ostafie is a precision agronomist as well and an articling agrologist. She came from a grain farm just outside of Canola and currently makes her home in Yorkton. Michelle got her agriculture degree from the University of Saskatchewan as well, where she studied agronomy. She joined us in the spring of 2020. So both Hana and Michelle work together to provide agronomy services to East Central Saskatchewan. They have clients throughout this region with a wide variety of agronomic challenges, often caused by soil-based variability. So today they're going to show us how they successfully use SWAT technology to help their clients overcome these challenges. They'll be highlighting fields from the Springside area. So I want to make sure to thank Derrick Burns of North River Ranch for allowing us to speak on a few of his fields. So thank you very much, Derrick, and take it away, Hannah and Michelle.
All right, thank you, Chris, for the introduction, and thank you so much to everyone else for joining us today. Without further ado, let's just jump right into more on SWAT maps and look at some specific fields from our region. Common challenges that we often see that reduce productivity and profitability are uneven maturity, lodging, salinity, and overall applying wrong fertilizer and seed rates in wrong areas of the field. We are going to look at why these challenges exist and how we can manage and improve them using SWAT maps. Uneven maturity and lodging is mainly caused by uneven plant stand, varying nutrients, organic matter, and mineralization throughout a field, and over and under applying fertilizer and seed rates in parts of the field. This diagram shows what years of tillage erosion has caused most of our fields to look like. The topsoil from the hills has eroded and deposited downslope, causing there to be much shallower topsoil depth in upper slope positions and much deeper topsoil depth in the mid-slopes and depressions. So think of upper landscape positions to be shedding and lower landscape positions to be collecting. Water moves downslope, and with it goes soil particles and mobile nutrients such as nitrogen and sulfur that are soluble in water. Water, wind, and tillage erosion moves soil downslope, leaving hills with low organic matter and low levels of immobile nutrients such as phosphorus and potassium that move with that soil. This means the hills, or the water shedding areas, have lower soil nutrient levels to begin with, but also they have less ability to mineralize nutrients from the soil, since mineralization is mainly a function of organic matter and moisture. Then on the opposite end, in the lower landscape, or the collecting areas in a field, they collect water, organic matter, and nutrients that the upper slopes shed. This means they not only will typically have an excess of soil nutrients, but they will mineralize a whole lot more nutrients such as nitrogen as well, often causing these areas to lodge and stay green for too long. Adding extra fertilizer to these collecting areas by flat rating a field usually makes these problems worse and can actually hinder your productivity instead of helping it. So why not move that fertilizer to the areas of the field that actually need it? So to reiterate that, this photo looks like a typical field in our region. Some farms we work with might be more exaggerated than this and be a lot hillier, or they might have sandier knolls, which we might choose to manage a bit differently. But in general, this is a good representation of what most fields look like. These eroded knolls with 2% organic matter might only mineralize 10 pounds of nitrogen, whereas these depressions with 6% organic matter could actually mineralize 30 to 60 pounds of nitrogen. This is just a generalization, since mineralization is really hard to predict and it can vary from year to year, and there are a lot of factors that influence it, but that gives you an idea of how much more these depressions can actually mineralize. So sulfur does follow the same mineralization patterns as nitrogen, but this photo is showing the actual soil test sulfur levels on this field. We see this pattern majority of the time where the hills have much lower sulfur levels due to runoff and leaching, and the mid slopes have moderate levels, and then the depressions are just loaded with sulfur. So which areas of this field are going to respond more to added sulfur fertilizer? It's not going to be the depressions that already have more than adequate levels in the soil. This photo is from our CropPro field at Nacum, Saskatchewan, which is where our head office is. So we had a PARS tour last summer, And we will be having another one this summer that you are more than welcome to attend. So on the left, we have photos of soil pits dug in zones 1, zone 5, and zone 10. Looking at the topsoil depths, you can see there's not very deep topsoil in zone 1, quite a bit more in zone 5, and then it's really deep in zone 10. And then on the right, we have the sulfur soil test levels corresponding to these zones. So we have zones 1 to 8 are all quite low residual sulfur. They're all under 50 pounds of sulfur. And then zone 9 and 10 are again loaded with sulfur at 160 plus pounds. We then did a 0 sulfur strip trial to see how the canola would respond to having no added sulfur fertilizer throughout the different zones. So zones 1 and 2 here showed deficiency symptoms throughout most of the growing season, whereas zones 7 to 9, you can see the plants look healthy and lush, and they don't have any sulfur deficiency symptoms. So why is that? If you think back to the last slide with the sulfur levels, zones 7 and 8 actually had about the same amount of residual sulfur as zones 1 and 2 did. But think back again to the topsoil depth in those zones, we're going to have a lot more mineralization in these areas compared to zone 1 and 2. And NACUM did get good rainfall this growing season, and so there was good moisture in these zones 7 to 9, so that helped with mineralization in those zones as well. Phosphorus, again, this is what it looks like the majority of the time. This Canola is quite low sulfur, so just for a benchmark, we usually like to see 15 to 20 ppm of phos in the soil, and this has 3 ppm, so it's quite low. It will 100% respond very well to added phosphorus fertilizer. The mid slopes at 8 ppm will respond well to added phosphorus fertilizer as well. And in the depressions on this field, we would just be looking more at maintaining these levels. All right, let's look at an actual field here. This is near Springside. This is one of Derrick's fields. Here we are looking at a 3D image of the SWAT map for this field. It is exaggerated, but this field is quite hilly, and as you can see, there are a lot of sloughs and potholes in this field. And then on the right here, just move myself, we have soil test numbers from, this is from 2018. So the wheat was applied in 2019, which means the soil test results were taken in fall of 2018. And then we also have the exact applied of fertilizer from the prescription that went in each of these specific zones. Zone 1, Zone 6, and Zone 9 and 10. Soil residual nitrogen on Zone 1 hills was 15 pounds, which isn't a whole lot left over. In zones 5 and 6, we had 24 pounds, and in zones 9 and 10, we had 67 pounds, which is quite high, and that means the crop the year before didn't take all that nitrogen up that was applied, and it'll likely, most of it will be lost. I should note that prior to this, it was flat rated, so hopefully as the years go on using variable rate, we won't keep seeing such high residual levels there, and we'll even out the residual levels across all the zones. Phosphorus numbers, 12 ppm on zone 1, 23 in zone 6, and 42 in zones 9 and 10, which again is very high. Sulfurs following the typical pattern we often see, 53 pounds in zone 1, and then zones 5 through 10 on this field had 160 pounds of sulfur. Now, if we look at what we actually applied in each of these zones, on this field, zone 1 and 2 had the highest fertilizer rates applied. So we had 125N, 51P, 43K, and 8S. And then we were using MESZ, so we had some zinc on there too. And then if we look at zone 6, we applied a little bit less. We pulled back to 110, 45, 38, 7. So this area would actually be the best yielding areas of the field. On this field, probably zones 4 to 7 would be the strongest yielding. But we still put the highest fertilizer rates on these hills because they have the lowest nutrient levels to begin with. They have the lowest organic matter, but they do respond really well to fertilizer. They're not too sandy. They will hold some moisture, and they can use it the most, and they will use that applied fertilizer. Zones 5 and 6, even though they're really good yielding, they do have higher organic matter. They've got more nutrients in the soil to begin with, and they might have some water collected in some of those areas. So we do just pull back slightly in those zones. And then I showed zone 9 and 10 applied fertilizer here because in zone 10 we actually pulled right off on the fertilizer. We just turned it right off. The salinity is really high, and we've got really high residual levels there too, and they don't produce well. And then zone 9, we pull back significantly there as well, but we put 64, 26, 21, 4. So the reason I mentioned how the hills produce and the midslopes produce on the last field is because in this area, it's near the White Sand River, it's near Good Spirit Lake, there are a lot of significant sand deposits in this area, and we don't want to manage those zones 1 and 2 the same as we might on a well-producing hill, such as in the last slide. So here we have a field that has these sand deposits in zone 1 and 2, and they usually dry out, so we don't want to manage them the same. Backing up a minute, this is a variable rate report that you would get from your agronomist once you've had your fields mapped, soil tested, and you discuss with your agronomist your fertilizer and crop plans. You would receive a report like this for each field. Here's a photo of your SWAT map for the field, and then at the bottom we have all your soil test results, zones 1 and 2 read across, zones 3 and 4, and so on. And we have notes on those soil test results the agronomist puts in, and then we have our yield goals corresponding to the zones, and then your rates of your different products in each layer. So wheat, NPK, MESZ, and potash. And that goes from zone 1 down to zone 10. So on the last field, the highest rates were in zones 1 and 2, whereas on this field, we don't think that there's value in putting as high of rates in zone 1 and 2 because they usually don't end up producing as well, especially in dry years, such as the last couple years. In the last couple years, these areas, they look good for most of the season until about flowering, and then they start to dry down. And this is evident in the soil tests here too, because we're not seeing the trend that we've been discussing previously, where the lowest numbers are in that zone 1 and 2. On this field, actually, the highest phosphorus level is 21 in zone 1 and 2, and that's not an error. That's because these areas historically haven't been producing as well, and so they haven't been removing as much phos. And as you can see, organic matter 1.5. So what we actually did here is pull back in zones 1 and 2 on both the NPK and MESZK we still put a higher seed rate there, but our highest fertilizer rates were actually going in that zone 3 to 6 range. Just showing that we don't manage every field the same, we don't manage every zone 1 and 2 the same. These are just, we're just looking at common approaches and common scenarios that we might see in the area. Now we're going to hear from Michelle for a bit.
So with uneven maturity, there are typically two different approaches that we take. One being applying fertilizer based on the fertilizer response. So as Hana mentioned before, there are varying factors for selecting fertilizer levels across the zones. Residual nutrient levels, the organic matter in each zone, the salinity and the pH, as well as soil and water characteristics. But the second approach is variable rating the seed itself. So as you can see, this picture on the right here is actually a prescription for one of Derrick's fields near Springside. And in this red box here is a canola seed layer. If you look at this top number here, 4.4, that is the seeding rate, which correlates with this red box, zone 1. And zone 1s are your hilltops, and typically in these areas there is lower germination and higher mortality rates due to either the lack of moisture or shallower seeding depths. And if you also look at the bottom here, this 4.8, this is the highest seeding rate across this field, and that correlates with a zone 10. So either those saline areas or depressions or water holding areas across the field. So again, lower germination rates, so a higher seeding rate is applied. And if you look at this zone 4 through zone 7, which are typically the mid slopes, you can see that the seeding rate is decreased in these areas due to the reason being usually there's higher germination in these areas and lower mortality rates. So this slide here actually shows a plant stand count on Derrick's field, which correlates with that prescription that I showed you in the last slide. So with SWAT maps comes two variable rate assessments, and the first one being plant stand counts. So we'll come out and perform plant stand counts on each crop type in every zone across the farm. And this example here is, like I said, Derrick's field. And if you look on the top, you can see that 8 plants, or around 8 plants per foot squared, were counted across all of the zones in Derrick's field, and an average of 8.4 plants per foot squared on this field. But if you look at the bottom here, this 26%, that's the mortality rate. So it has a pretty high mortality rate in zones 9 through 10, and then, which are those depressions. And then if you look on the left here, this 19% mortality rate in the hilltops, zone 1 and 2. So it just goes to show varying the seeding rates in appropriate areas, you can still have the desired plant stand count and an even plant stand count across the entire field. Something else when we do come out, when we are counting, we're also taking note of the staging of the crops per zone. So we want to make sure that there is even staging across all the zones, and if there's not, we're going to take note of it, and we're going to alter rates for the following year to help even out that staging. Then when we're also out when we're also out doing a variable rate assessment, we are also checking for any other issues or potential improvements or other yield limiting factors that we can let the farmer know about on his field. So the second variable rate assessment is called a pre-harvest assessment. And with a pre-harvest assessment, we come out and we take a look at the field just before harvest and ensure that there's even maturity across the entire field and no lodging. If there is lodging, we want to make sure we narrow it down to what zone that lodging is in, and then alter the rates for the following year to help mitigate that lodging. And then this picture in the back actually shows or represents what we would want a variable rated SWAT map field to look like, nice and even across the entire field. So there are a couple benefits to having an evenly maturing field, one being improved disease control. So with diseases, there's typically a short window for controlling them, and one being fusarium. So with fusarium, you want to make sure you go out to the field and you want the field to be flowering all at the same time. So with that, you're usually applying a fungicide not only on at the correct time, but on a higher percentage of the field. And then you have overall improved disease control and then the potential of a better grade and an increased profit. And then the second benefit of having an evenly maturing field is having even maturity for harvest. So pretty much just gives a farmer a sense of ease, not having to worry about shelling out hilltops and late maturing depressions. They can go in all at once, harvest all in the same day, and then not have to worry about coming back a week later to get what was missed. So these pictures were actually taken by Hana last growing season, and the top two pictures represents a field that was variable rated with SWAT maps, and then the bottom two pictures represents a field about a mile away from on the same farm that was just flat rated. So these top two pictures, if you look at the zone 2 and the zone 8, they have pretty similar stage timings. Whereas if you look at the bottom left picture, this is most likely a zone 2, and there are several heads poking out. And then the bottom right picture, which is likely a zone 8, you can see that the heads are just cracking the boot, if not hardly cracking the boot. So it just goes to show the benefit of variable rating can help with even staging and even maturity in the end as well. Now we're gonna go back to Hana talking about salinity.
Thanks, Michelle. Looking at salinity. So first thing to note, salinity is a water table problem, not a surface drainage problem, which means it can't be fixed unless you actually fix the water table, such as using tile drainage. SWAT maps won't fix your salinity or get rid of it. However, we can use SWAT maps to manage these areas more efficiently and prevent adding to the issue by adding more fertilizer and salts to these areas. It can be managed a number of different ways and can vary from field to field. Two common ways that we'll manage it is in cases of marginal salinity, you might increase the seed rate and decrease the fertilizer rates in order to increase plant stand in these areas, but not add any extra fertilizer there. And then in cases of very high salinity, we might decrease both seed and fertilizer rates, or just altogether turn them right off depending on the field, as these areas are unproductive and not worth spending money there. Looking at a specific field, this field is between Norton and Canola on highway number 9. Zone 10 is very saline, 4.32. Not much grows there. There is a lot of kochia that grows there, but not really crop. And zone 7 and 8 are also quite high in salinity, but we will get a crop there. It's just usually a reduced stand. How we chose to manage it in this specific year is, in this case, we did still put the highest seed rate in zone 10. With this high salinity, you might not always do that. You might decide zone 9 or 8 will be your highest rate and will actually pull back on this seed in zone 10 because it's not worth it to put it there. In this case, the seed is a little bit cheaper, say, compared to canola. So we did decide to just put a high rate there and see if we could get a bit more plants to germinate. But we did totally pull back, or totally turn off the fertilizer in zone 10 and pull back significantly in zones 8 and 9. As you can see, 2018 previous years were flat rated up until now. We have quite high residual in zone 9 and 10 here, which, as I said, crop's not really growing there, so that extra fertilizer that's left over is going to be lost, or the kochia is going to use it. These zones, zone 7 to 10, compared to the rest of the field that year, are quite high. So then this is how we managed it, turn the fertilizer off there. And by the next year, we had brought that zone 7 to 10 saline areas down about to the rest of the field. It's still a little bit higher, but we did bring it down significantly and already started to feel better knowing that we weren't wasting money on fertilizer there. Next crop, so last year was canola here. And as you can see, due to the dry conditions last year, we have overall higher residual rates of nitrogen, but the field remained quite even. Zones 7 to 10 are basically the same as zones 3 to 6, and actually the highest residual was on the dry zones 1 and 2 because they kind of dried up later in the season. We've now looked at 4 main issues that we see across most farms and how SWAT maps can help manage and improve those. This is taken from our website, CropPro.ca, and there we have a list of 10 agronomic and environmental benefits of SWAT maps, and I encourage you to go check that out. Today we've discussed the top 4 on that list, which is ROI out of applied nutrients, even maturity, lodging, and managing salinity. Just a reminder, not all VR is the same. SWAT maps are based off soil potential, not yield potential, such as satellite imagery. We take a strong boots on the ground approach and rely heavily on agronomy. That's why our agronomists meticulously ground truth so that we make sure that we pick the right map for each field and are starting off with the right map so that our soil tests are right and our recommendations are strong. And one last thing, the software we use is SWAT Records, it's previously known as Crop Records, now called SWAT Records. So anyone can download this for free and utilize it. You can enter your crops in and do scouting on there. This is what we all use for our scouting clients. But once you get some fields mapped and you're a SWAT Maps client, you'll be able to bring up each SWAT map on your phone or your iPad, and you can see where you are in that field and use it for elevation or drainage, and utilize the app as much as you want at a free cost. Thank you for your time, and I think Chris is going to say a couple more things now, and then we'll move on to questions.
Okay, I hope everyone can hear me now. Thanks a lot, Hannah and Michelle. I appreciate that information. And just want to encourage anyone that has questions to please go ahead and use that Q&A button at the bottom of the screen. Press the button, jot the question in there, and we'll be sure to answer it for you. And while you're thinking up some questions, I'll just go through some details on our mapping credit that we're offering. So we're going to give $1,000 credit to those of you in attendance if you map at least 160 acres this spring. So if you're a brand new client to us and you've never mapped before, that's available to you. Simply just put your name and phone number. We already have your email, I believe, but put your name and phone number in the chat box, and that way we can be sure to get in contact with you and go through some finer details. That chat box just comes to us as panelists, so feel free to share it in there. Existing clients, you also have an opportunity to get the $1,000 mapping credit if you referred one of these new people to this webinar. And of course, if you're in the webinar now yourself, you simply just need to map 160 acres. And then that has to be done this spring as well. And also let us know which person you referred by using the chat box on the bottom of your screen. So those are some quick details about the mapping credit. Looking for a few questions. I know that there's one question that might pop up. Hannah mentioned earlier in her presentation about our PARS tour. We had some soil samples that she was showing you there with different organic matter levels. In case you're not aware, PARS is our Precision Ag Research Site, and that's in Nacum. And last year was our first year, was really, really successful. So I'd strongly recommend you stay tuned for that. Maybe there's an opportunity for you to come again this summer when we do it in July and probably August as well. We ran it over a few weeks because of the limitations to the amount of people that we can have. So contact information is available on this screen here. You can see, you can reach out to any one of the 4 of us if you want further information. Maybe you don't want to ask your question here on this forum. You're certainly welcome to reach out to any one of us by phone or by email, and we'll be happy to get back to you. and answer any questions you may have. So I don't know, maybe Hannah and Carrie or Michelle, if you have any other comments, things that we might want to add to this, but I believe that covers all the bases. I don't have any questions that came to me. Coral, did you have any questions that came to you? I'm not seeing any. Oh, here's one question. The question reads from Chris. It says, every field, no matter the size, has 10 zones. And that's a question. And I could answer it, but maybe I'll let you, Hannah, take that one.
Hi, thanks for the question. Yeah, every field has 10 zones. So even if it's a pretty relatively flat field, or you think it's not as variable as some of your other fields, it still has 10 zones, but we can manage them differently. So we might have the same rates going in zones 1 to 5 on that field, but it still has 10 zones.
Right. Now, there may be some extreme circumstances that come up. Maybe you've got, like in Eastern Canada, where we've got really small fields. It's a little bit of a different scenario. They may treat it a little bit differently, but here in Western Canada, we're primarily looking at 10 different zones. So any other questions that anyone wants to offer? Everybody must be shy this morning.
There's a question in the chat, Chris.
There is? Okay, I'll find it. Okay, how long does it take for a field to go back to zones? Okay, how long does it take for a field to go back to zones after being flat rate fertilizer for years? To go back to zones.
I'm thinking what they might mean, and you can add more in the chat if I'm wrong, but what they might mean is the residual nitrogen levels, how I was talking about, especially in the lower zones, like zones 8 to 10, often when we first map the field, it will have really high residual in those zones. And then as we manage and start pulling back fertilizer rates there, it starts to even out across the zones. Is that what they mean?
Yeah.
But if that is the question, it usually doesn't take long. It'll start going down after the first year, and then, I mean, it all depends on the year, the field, and how we manage it, I guess. But you'll start seeing it go down after the first year.
Yeah, there's a lot of factors that influence that answer.
Yeah. Looks like that was what they meant.
So here's another question from Brent. It says, how would SWAT maps help if you are not able to variable rate this coming year? And I presume that must be if maybe your equipment's not able to do it yet, or if there's I guess the question might be, is there value in having SWAT maps without the ability to do variable rate this year? Hannah or Carrie or Michelle, who wants to take that one? We'll give Carrie it. Okay, go ahead.
I mean, if you're curious about soil test levels and you know in the future you would like to variable rate, then you might as well put that money into getting your field map, because the map doesn't ever change. So then the only thing that changes after that from year to year is your soil test. So if you get it mapped and then you have a good basis for soil test results, if you're curious about that at this point, and then once you're set up for variable rate, then we go from there and re-soil test for that year and still use the same maps. I don't know if anyone has anything else to add.
Yeah, so the maps do become permanent. So even if you do it a little bit early, it's not like it's not going to be to your advantage at some point. So yeah, that covers that. Another question here. This is from James. James is asking, how does your program differ from others offering modified grid sampling? So maybe Carrie, you want to take a shot at that one?
Yeah, I guess one question would be, how do we, or what are the modified grid sampling, or what's the grid sampling based on? Like our map is based on the soil, water, and topography attributes, And sometimes grid sampling might miss that. You might have a hill and a depression all in a 1 acre grid zone, if that's what you're doing. That would be one one major difference. Not sure if I answered. I don't know what the modified grid sampling means.
Yeah.
If you could clarify that. Some grid sampling is just 1 acre grids, and
that's right.
That's how we're different compared to that. But
yeah, I think that's a question that maybe requires a little more detail and just to see exactly what the comparison would be. But typically speaking, as you were mentioning, Carrie, a grid is in a square. And if it's only 1 acre or whatever the acre size is, there can be more than one zone that goes through that particular square. So it wouldn't maybe accurately indicate what's going on in the field in that area properly. So anyway, that does require some deeper discussion. So if you want to leave your contact information, we can certainly go through that with you, James. Okay, so here's another question from Curtis. How do we receive the maps? Well, there's a couple of different ways you can receive the maps. Michelle, do you want to take that one or do you want me to take it? Go ahead.
Yeah, so pretty much we'll start off by obviously ground truthing and picking a map as to which one best suits your field. And then from there, we send that specific file that we had chosen and send it off to Tracy, and then she'll convert it into, I guess, a map that is usable in a usable form for the farmer. And then the first step would be Chris coming out for the first time, and he comes out, you'll come out once and you'll upload that map and those files into the equipment, variable rate equipment. And that would kind of be the way you receive the map off the start. And then for the following, I believe they are emailed, if I'm not mistaken.
Yeah. They can also go through the cloud, depending on the electronic equipment that you have. Like maybe you have the John Deere Operations Center, then we can work through that. Maybe you have a Seed Hawk system with an icon monitor that also has a cloud-based system. So depending on whatever your tool is, we can certainly upload your maps that way. So I presume when you say maps, you're referring to the actual prescription. That's the way we answered that question. I mean, if you just want to see a picture of your map, like the SWAT map that Hana and Michelle were showing, then that's something that can be emailed to you, or you can actually see that map physically in your SWAT records mobile app. We can just have we always have the files in there, and you just go up to the maps and files location of your app and find the appropriate field, and your map will be in there. But it's not the only map you see. You don't just see a SWAT map in there. You may see all the soil sample points. You may see, if you ask for it, we'll give you an elevation map as well. We don't actually charge our clients for an elevation map. So that would be in there as well. And there's other information, depending how extensive you want to be in your analysis. Maybe you have, we're doing lots of work with water maps and stuff. So that's for another conversation, but it's all in the app. Okay, so next question. Oh, I guess that isn't the next question. Yeah, go ahead.
Yeah, that was me. Okay. Just in case he means after this webinar, like what's the next step? I don't know what they could have meant, but we'll contact, if you left your information in the chat box, then we'll be in contact.
Curtis, I have your contact information. So if you want me to reach out to you, just let me know, and I can answer your question more specifically. So looks like we have a few more questions. This one's from Bevan. Have you got into variable rate fungicide and chemical application rates? Well, that is a good question. Who wants that one? Somebody wants that one. Go ahead.
Hana, have you actually done any of that yet? I can answer it.
Yeah, I've had one client, I think, do it so far, and it worked good for him. We just did on-off fungicide application, but Carrie, you can go more into it if you want.
The VR fungicide, yeah, that's easy enough. You just do on-off prescriptions based on if there's crop or not, or how the crop's looking. The chemical application rates, that's one thing we've done is with soil applied products. You'll see on the label of those soil applied products, it talks about what the application rate is by organic matter and moisture levels and things like that. So with SWAT maps, we can vary the rate of some of those soil applied products based on what your organic matter is. So you're not over applying on the hilltops, and so you're applying enough in the depressions, which typically are higher organic matter areas. So we've done some of that as well.
Mm. And there's a follow-up to that. Hey, Carrie, the question was around top dressing.
Top dressing, that's, yeah. Same kind of idea as VR fungicide. We can use satellite imagery for that, or we might use our zone maps. It kind of depends. We go out and ground truth. If we're using imagery, we'll ground truth the field for that and make sure that we're turning on the fungicide or top dressing in the areas of the field that need it. But yes, we've done quite a bit of that.
And we're starting to do more and more. Derrick Rood is our research and development manager, and he's been doing a ton of work with SWAT CAM. And he just made a comment in the chat there. If you want to, I guess it might be just to us, but his comment was that SWAT CAM will enable variable rate herbicide once it's commercialized, and that's coming in the near future. And SWAT water is another process that we're working on, and that will enable variable rate top dressing as well. So these are some things that we're working on, and actually SWAT water is coming onto the marketplace this spring, so we can give you more details on that as we move forward. Was there another question here? David is asking, how long does it take for a field to respond to variable rate treatments? Boy, that's a loaded question.
Well, I could answer it, or
Sure.
part of it at least. When Hana showed that picture of the phos variability throughout the field, for example, and the areas of the field that had really low phosphorus levels in the soil test, right away those areas of the field will respond to more fertilizer. So that's one way to answer that, I guess, because we're basing it on the soil and the soil tests. We're putting the fertilizer where it needs to be. So field will respond to fertilizer right away.
Right. Yeah, and there's also consideration as to how much nutrient is in the soil and a variety of climate conditions that will affect how quickly it responds. And yeah, there's lots, as in agriculture in general, there's always lots of factors that influence that. Okay, what is the satellite imagery resolution used for VR fungicide, etc.? And that's from somebody anonymous. What is the imagery resolution used? I should know that, but I don't know the exact answer to that. I know that we probably have.
It's 10-meter resolution
for that process. Okay.
It's Sentinel imagery, and it's 10-meter resolution for that.
There you go. That answers that. And that's very good. Next one is a question from Keenan. Do you blend maps based on implement width? Yeah, do you blend maps based on implement width when one end of the machine is in a low spot and one is in a hill? That's a good question.
Chris, you're good at explaining this.
I can answer it. Yeah, I can answer that. That depends on the implement, I guess. If you're dealing with a piece of machinery that can do only one rate across the entire machine, then that's the rate we work with, and it's based on where the antenna is in the tractor. That's the zone that it's in. So that's the rate that it's going to be. So we try to consider the width of the machine when we're doing our prescriptions, so that it makes the most sense based on the different zones that it's in. But as you get into more and more capable equipment, there are some out there that'll do variable rate. They will change the rates by section, and those ones we don't have to blend the rates quite as much, when we can be a little bit more precise as to what rates we want in each of the zones. Does that cover that, girls? Is that the way you would say it? Okay.
So Derrick, think it might be Derrick Burns in the chat, also said for a response to the last question that he personally has seen a response in the first year of using VR with SWAT maps.
There you go. Thanks for that, Derrick. Okay. Now, do we have any other questions? Oh, yeah, we do. This is a question from AH. Do you take yield data into consideration for making maps? If not, why is it not taken into consideration? Who wants to take that one?
I can answer that. We
Sure.
we do take yield data into consideration. The caution with it maybe is if an area of the field says it's yielding low, our strategy might not necessarily mean that we're going to fertilize it for a low yielding crop. Maybe it's yielding lower because it needs more fertilizer. But overall, we do take yield data into consideration, and we can modify some strategies based on what's been going on over the years and your fields and your crops. Hannah, do you have anything more to add to that?
Yeah, I was just gonna say I use it sometimes specifically when ground truthing. If you're seeing something odd out in the field while you're ground truthing, lots of the time you'll look at that and try and learn more. Is it continuously yielding lower, and try and help it, I guess, for picking the right map and making sense of what you're seeing in the field.
Mm-hmm. And this is all operating on the assumption that the yield data is relatively accurate, which is sometimes suspect, especially the more combines you get, the more challenging it is to get accurate yield data. But yeah, it's something we look at. It's just not something we rely on when we're making our maps. Is that fair to say? Okay. I don't see any more questions in the Q&A. Did I miss any in the chat? I don't think so. Okay, well, I mean, we've been on our call here, on our webinar for about an hour. So I just want to remind everyone, if you don't mind, if you do want more information, please put your contact information in the chat box. Maybe you want to ask questions privately about pricing or about other options that we have available, such as the SWAT water program or anything else that we're working on. Just certainly let us know. And especially regarding the credit, if you want to take advantage of that $1,000 credit, we need to know who you are. Have I missed anything else? I think that covers it. Well, everyone, thank you for your time. Sorry, what's that?
I was just gonna say, if anyone does have more questions or wants more detail on some of the answers that we've given, just feel free to give any of us a call or text or email.
Yeah, I don't know, Coral, if you want to put that contact information slide back up, is that possible? Then we can leave that up for anyone to take a look at. But thank you, everyone, for taking the time to join us, and we'll look forward to catching up with you at some point down the road. And we'll let you screenshot or type or write down these contact numbers or whatever. But that should be it for us, so we can close. Thanks for your time.
Thanks, everyone.
Thank you.
Thank you.